All right, guys, this is notes that go with the Circles one-pager. I'm going to link this to your video here. You can print this out or you can take screenshots and stick it in your own Jamboard if you want. And we're going to go through all of the rules we've learned for the Circles unit and just review all those different rules. So the first one is this one, and it says that angle A equals 1/2 angle B, which is true. So an example of that would be like if I tell you that this angle here is 25, that's called an inscribed angle. Then you would know that the angle here, which is called the central angle, is 50 degrees. And you also know that the arc right here is also 50 degrees. So the inscribed angle is always half the arc, and the central angle is always equal to the arc. So that's the first rule, and it's probably the most important one. The next one is here. It says angle A equals angle B. So you guys can see angle A right here is going to point at these 2 points on the circle. Right here to right here. And angle B is going to point to those same 2 points. And so because angle A and angle B are both formed by the same arc, they're going to both be the same. And so we can make up another rule about this. If this was 70 right here, then both of these would have to be 35 because these are both inscribed angles and they're half the value of their arc. So angle A does have to equal angle B because they both intercept the same arc. All right, the next one is talking about this angle right here, angle B. Because angle B points at these 2 points, which happens to be a diameter, anytime your arc is a diameter or a semicircle, that means the angle it forms is always going to be 90 degrees. And you know that because a semicircle is 180 degrees, and our inscribed angle, right here, angle B is our inscribed angle, would be half of 180. Half of 180 is 90. All right, the next one is showing you a radius. This could also be a diameter. Could go all the way across. And it's hitting a tangent line. The line that just glances off the outside of the circle at one point and doesn't go into the circle is called a tangent. You have to know that. And when a radius or a diameter hits a tangent, it always intersects it at a 90-degree angle. So that's just showing you that. This next one is a tangent and another tangent. And whenever two tangents meet at a point outside the circle, in this case they're meeting at point P, then this section of the tangent that's outside the circle is equivalent or congruent to this section of the tangent that's outside the circle. So this section equals that section. Okay, and this is good for those problems where you have a circle inside of a shape like this. So you would know that this part equals that part, this part equals that part, and this part equals this part. Okay. This next one is pretty easy. The drawing here is complicated, but I'm going to color code it for you. So we have section A and section B. So A times B has to equal, nope, I'm doing the wrong thing. Sorry, guys. Section B is this whole thing. There we go. C times D. C times D. So the tricky part on this one is that it's the outer part, like this green part, times the whole thing. The orange line is the whole thing, so you might have to add something up. Like a good example would be if they tell you that this is 3 and this is X and this is 2 and this is Y, we would say 3 times the whole thing, 3 plus X, equals 2, the outer part, that's this purple part, times the whole thing, the whole red part would be 2 plus Y. So you have to put it like that, and then you'd have to distribute this. And of course you couldn't solve this because I have 2 different variables, but if you had all X's, you could put it together. The next one, let me get a clean sheet here. The next one is, whoop, I dropped my camera, sorry guys, is, I think the best way to write this formula is angle equals 1/2, you can use 0.5 if the fractions bother you, use a 0.5, arc 1 plus arc 2. So that's the formula that needs to go with this, and I'm going to show you what those are. So, for example, if I'm finding this angle right here, this would be arc 1, and this would be arc 2. So arc 1 is the one that would normally go with it, and then arc 2 would be the one that's with its vertical angle. Or if I'm finding this angle right here, the purple angle, this would be arc 1 for the purple angle, and this would be arc 2. Okay, so it doesn't matter which part of this you're missing, just stick an X in for whatever part you're missing. You could be missing the angle, or you can be missing one of the arcs, but you can use this formula. And don't forget that these are not central angles in this picture because they don't go through this center point O. So even if I knew that this green arc right here, let's say that was, I don't know, let's say it was 140 degrees. Okay. That's way too big for that, but that's fine. That doesn't mean that this E would be the same as 140. It also doesn't mean that E would be 1/2 of 140 because this is not an inscribed angle and it's not a central angle. So you can't use the 140 to find this unless you also have arc 2, let's say that's 80. So then I would know that angle E equals 1/2 of 140 plus 80, and you could solve that. Okay. All right, the next one, let me see if I can find that. Couple of things going on here. First of all, if anytime you have a radius, which this isn't a full radius, they didn't keep it going, but that's fine. Anytime you have a radius or a diameter that hits a chord at a 90-degree angle, it's going to break that chord into 2 equal chunks. It's going to bisect the chord. And so these green lines are bisecting these orange lines like that. Okay. Also, if you have chords that are the same length, let's say these orange chords are the same length, that tells me that these arcs are also the same length. So the purple arc equals the purple arc. And because the orange chords are the same length, that tells me that they must be the exact same distance away from the center. So that means this green line equals this green line. Let's do it this way so we don't get confused. So a lot going on here. If the orange chords, the orange line is called a chord. If the orange chords are equally far away from the center of the circle, that means they're equal in length, which means their arcs are also equal in length. And if a chord is cut in at a right angle by a radius or a diameter, then that means that that chord is cut into 2 equal pieces. It's bisected. So in this case, line segment PA up here would be equal to line segment AQ. And we know that arc PQ equals arc SR, because the two orange chords, the whole thing, because PQ equals SR. And that's true because AO equals OB. They're equally far away from the center. So a lot's going on in this one. All right, next, get a new sheet. This one's called the tangent secant rule. This green line is a tangent. Even though it doesn't keep going, it's just going to hit my circle at one place, on the outside there at one place. And then this purple line here is a secant. Okay, so the rule says that the tangent, that's DC, times itself, equals the outer part of this, CB. Let me put that in blue. Times the whole thing, CA. And so let's put some numbers in here so that we can make this work. Let's call this X, and let's call that 8, and let's call this 5. So I know that 5 times itself equals X times the whole purple line, this whole secant, which would be X plus 8. So you'd have to distribute. This would be X squared plus 8X equals 25, and that's not going to work out to be something easy to solve, but that's how you would solve it. All right, last but not least. We already talked about this. This is an easy one. I kind of combined it with another one. This is saying that if that arc AB equals arc BC if and only if these two chords are equal. These red ones are called chords. And so if the chords are equal, then the arcs are equal. That one was already covered. Okay, so I hope this helped you sort of look at the rules, and if you want to print out this sheet and use it on your upcoming tests, or use, I think we're going to let you guys use a little cheat sheet, like a little note card or something, so talk to your teacher, and we'll decide what you guys can use. Some sort of version of this where you have everything on one page, okay? All right.